So for inletting these locks, what I do for the internals is I start by just putting the bridle on and just inletting the bridle, and try to get close to depth and leave just a little bit below depth, so that it's not actually binding on anything. But I want to remove the least amount of wood possible. And obviously on this style of lock, with the way the spring sits and the where the motion is, and the sears and whatnot, are going to be a lot of wood's going to come out of this. It's going to be pretty hollow in here when I'm done. But the idea is to take the minimum amount of wood out all the way around and only take it to depth, to where it just goes to depth and then leaves you enough clearance for everything to move properly. So that's what I'm going to work on now, is getting these springs inlet and opening up this area, and I'm going to try and stop my depth to where it just gives clearance for the springs to move. Okay, so next step is to start inletting for this sear, and that requires drilling a hole. And you'll notice that on these back action locks, the sears run right to the edge of the faceplate, to the lock plate, and so you want to be real careful drilling this hole. And I'll show you how I do it. It's real simple. I go ahead and use my screw holes to index my lock so that I know where it's going to sit. And then what I do is, before I drill the hole, that sear arm sticks right onto the wood, and so I'm able to stick pencil in here and rough mark it and get my idea of where it's going to be. And then the tool that I use to drill this hole is, I don't use a power drill for this. Running that close to the edge, if it happens to catch or twist or bump or anything, you're going to tear out the edge of your wood, and that'll require at the very least a repair and possibly a restock job. So what I use is the good old-fashioned egg beater. Kind of a simple old tool, been working for a couple hundred years, and it's really easy to run, and it's really super easy to be very precision with it, and be slow and take your time and get a real controlled hole. And so you'll see that drilling this hole, I got right up to the edge of the wood without busting out the edge on the surface, and that's really what I wanted to do. So sometimes going back to the old school really helps a bunch, gives you a lot more control. Takes a little bit to drill a hole this way, because obviously you're not going to just run it right in there. You're going to have to do a little hand in and out, cranking it in and backing it out and clearing chips and stuff. But if you really want a precision hole, good old egg beater works good for that. So there we go. You can see all the different pockets and depths and everything that it takes to get a lock to fit in there, and you can see that everything's got its own shape and contour to make, for each piece, so that it's got enough room for movement. And that's just the way it's done. Not much more I can say about it. Basically, I explained it earlier, that each piece, one piece at a time, and inlet it down in there, make clearances for the movement of the springs and for your sears and stuff. And that's about it. I'll slip this in here so that you can see what it looks like. And it is a pretty good fit. There we go. Of course, if I had a trigger in here, I could work it a little bit, but I'll get the other locks done, and then I'll do the triggers and show you where it looks like from there. So there's a pretty tight fit right through here, and so I think I'm going to have to take some off the hammer, but I was planning to reshape these anyways, to give them a lighter, more graceful look. These are kind of heavy looking hammers, so I'm going to give them a little more graceful look, and when I do that, I'll take a little off this back here and give it a little clearance against the wood. That's it. Of course, it's missing the stocking safety, but that doesn't affect the inlet at all. So there we go. As you can see, I got the other lock side in. All the internals are in. Once again, the stocking safety's been left out, but it doesn't affect the inlet any at all. So the next step is to inlet for the two triggers, and that doesn't take a lot of time, but it's really pretty easy. It can usually be done with a Dremel if you're kind of careful, not to break the bridge in between the wood down. The only part of the triggers that really needs to have some time and care spent on it is making sure that where they contact the sears, where the end of the trigger bar contacts the sears, is a really close, within a few thousandths tolerance fit in all positions. The reason for that is because you don't want to pull in any slack. You want your triggers to be crisp, and then in order to make the triggers stop, these are still tightly fitted right at the minute, and I'll work the metal at the back side of the trigger until I get it just to a perfect stopping point to where the sear lets off, clears as much as it needs to, but the trigger stops dead by hitting metal to metal, trigger to trigger plate. So it takes a little bit of fitting to do the metal work, but other than that, it's pretty easy to do the inlet into wood. I wanted to show you how the sear, the interrupting sear, and the trigger bar work, and what kind of fit you really want to kind of shoot for to make these things really function properly. So this would be the left side of the gun here, looking down through it to the right side lock, the internals of the right side lock. So in here you can see that this here is the trigger bar. There's the regular sear, and there's the interrupting sear. And right now the hammer is in the fired position. It would be all the way down to the firing pin, basically. And so what I'm going to do is I'm going to work the hammer and show you how these things interact. You can see that there's a little gap between the interrupting sear and the trigger bar in the fired position, but the sear itself, the actual trigger sear, is resting against the trigger bar. And so as I work the hammer, you can see how they open up and interact, and there's the half cock position. At the half cock position, you'll notice that the interrupting sear and the sear are both now contacting the trigger bar, and that's really what you want, because when you take it off a half cock, and kind of running out of hands here to hold the flashlight and operate this, so bear with me. When you take it off a half cock, what it actually does is you pull back just a little bit, pull the trigger, and you can see it works both at the same time. And then of course that opens it up to the original, starting position with the gap in the interrupting sear, but the sear is still contacting the trigger bar. So when you go back to half cock and then all the way back to full cock, you can see it move again, and you hear a nice good solid snap, and you can see that the sear and the interrupting sear are both contacting the trigger bar, and that's really the ideal fit right there, where you've got a good hard fit on the sear and a light touching fit on the interrupting sear. And that way, when you pull the trigger, it moves the interrupting sear away from its contact point just enough to allow the sear to clear and the tumbler to roll free without the interrupting sear engaging and keeping it from moving. And I'll try and show you that. They both move together, and that would put you in fired right there. So that's how it works. And I'll turn the gun up on its side here and show you what it looks like from the side, so that you can see how everything interacts and works just fine. But that's how the sears are supposed to fit. The sear and the interrupting sear and the trigger bar should all look like that, so that they're making just the right contact, so that everything functions perfectly but is absolutely safe. So here it is. I just flipped it over so you can see how it works from the outside. Hammer's all the way down in the fired position, and obviously, like I said before, I've got to reshape this, do a little adjustment to get everything lined up just perfect, but for demonstration this will work just fine. The half cock position, and then of course the trigger's nicely engaged in the half cock. Hammer won't fall on the half cock without some serious force. You can, most half cocks work really well and they're really reliable, but you can actually force these past a half cock. It actually ends up breaking the tip of the tumbler off, but if you drop a gun, it's possible to do that. So I don't particularly rely on half cocks as a safety measure in these kind of guns. And of course, if you pull back just a little bit and then pull the trigger down, it lets it off the half cock. So half cock and then full cock, and if you pull the trigger here, the sears release, the intercepting sear releases, and everything fires just fine. If under recoil or drop the gun or something like that happens and it knocks the sear loose, just the engaging sear, the intercepting sear catches the hammer and prevents it from dropping down, just like I had showed in one of the former videos about when I was building these locks and doing the intercepting sears. So that's how it's supposed to function. Those are the kind of tolerances and fit you have to get to make everything work just fine. And you'll notice that because the primary sear rests against the trigger bar all the time, there's no slop in the trigger. It doesn't have any play in it. It stays really solid. And you'll notice there's not a lot of motion in this. That's a real, crisp trigger pull, and it doesn't move very far. It stops dead after just a very short pull. That's the total amount of movement in the trigger right there. So that's really ideal. I mean, it's a really crisp precision setup. The pull on these triggers is about 5 pounds. Of course, I could lighten that up a little bit if I wanted to, but I don't really want to do that on a big bore double rifle like this. I want a guy who's pulling these to be absolutely confident in what he's doing. And so I don't want a very light, precision trigger pull. 4 to 5 pounds is about right, and these are about 5. So really crisp, really clean. Obviously, the only other thing is the stocking safety would engage right here at full cock. So that's the way it works. I'll get the other trigger installed, and hopefully everything fits just as nicely, and we'll go from there. So the next step in this is to see if I can do something about counterbalancing the weight on this thing. The barrels, because they're so long and such a heavy profile, they really make this gun very muzzle heavy. And I knew this was going to be a heavy gun to begin with, but this thing's really kind of beyond normal for being muzzle heavy. And so I want to do something about trying to balance it out a little bit. Obviously, because the gun is so heavy, I don't really need to put any weight in the back of this thing for recoil purposes, but I do need to do something to try and make it balance better. Really, a double rifle should swing like a fine shotgun. It really should handle very well, and the weight and balance point should be comfortably between your hands when it's shouldered up. And so in order to do that, what I've got here is I've got 4 13-ounce recoil reducers, just standard Braco. And when I built the single shot T-War cartridge gun, I actually used 3 of these. And what I did in the single shot was I really was trying to add weight to the single shot and make it balance both at the same time. And so when I did the single shot, what I did was I double stacked these. They're threaded for a 1/4 inch thread. And I double stacked 2 of them, and I stuck 2 of them in the butt this way, and then drilled a second hole and put a second one closer to the rear of the butt. And that worked out really good in the single shot, but because it put some of the weight more forward and then leaving one at the back gave it a nice balance point. With this one though, because of the barrels being so long and so heavy, I really want to leave all the weight as far back in the buttstock as I can, and I'm really not sure I'm going to be able to get all 4 of these in here, but it looks like there's enough space I probably can. What I'm going to do is obviously these 3 are going to go right in the center line, but they're going to be at a slight angle. The reason is I'm going to tip them at a slight angle and try to really be careful to leave plenty of wood up at this point here. But the reason they're going to be at a slight angle is because if I can get this 4th one in here, it's going to have to sit at an angle. So it's got to come in at an angle that matches the toe line of the stock, and in order to do that and get the next one in on top of it, I've got to cant all 3 of these at a slight angle. And that really won't hurt anything, because like I said, I'm not using these to try and reduce recoil. This gun already weighs way more than I wanted it to. What I'm really just trying to do is add some weight to give it a little counterbalance point and get it into a position where it's actually feels like it's supposed to feel, hopefully. Like I said, I'm going to try and drill these and be real careful doing it so I don't break through anywhere, and then I'll stick them in there, see how they look, check my balance and everything. Hopefully these 3 weights, or these 4 weights, are going to add about 3 1/4 pounds to it, and that hopefully leaving all that weight at the very back will balance it out a little better. I had the gun all together yesterday, now that everything's inlet and everything's kind of roughly shaped out, and put it on my scale, and without the weights on it, it weighed right at 39 pounds. So adding 3 pounds, 3 1/4 pounds, it should weigh somewhere in the 42 pound weight range, 42 1/4, somewhere in there. So hopefully that's how it's going to work out, and I'll get those in and put everything back together and see what it feels like and see how it weighs out. So you can see I'm drilling this bottom one by hand here, and the reason I'm doing that is because these sidewalls down here in this bottom wall are only about 1/4 inch, and there's only about 1/4 inch extra wood around these edges, and so drilling by hand I can have a lot of control over what I'm doing. I can keep my bit and brace running real straight and parallel to the center line of the stock, and more importantly though, if I was drilling this with an electric hand drill or even a drill press or something, if this bit happens to hit a hard spot in here and catch, chances are, with as thin as this is, it'll crack the stock. And so to prevent that from happening, drilling by hand, obviously, if it hits a hard spot or something, you know, it'll stop, and my hand will stop, and I can back away from it before I do any damage and come at it, you know, slowly, and just kind of work my way through the hard spot without having to worry about blowing out one of these thinner sidewalls. So this bottom one and probably this top one I'll probably drill by hand, because I know when I get down into depth on the top one, it's going to probably be only about 1/4 inch of wood at the very top of the comb. So these two I'll probably drill by hand just to be careful, and then the other two, you know, they have enough wood thickness around them, I should be able to carefully drill them in my drill press or with a hand drill if I needed to. But for these top one and bottom one, I'm going to go slow and careful and just take it easy with a hand drill and put a couple real nice holes in there, and that way I don't have to worry about blowing out a side anywhere here or cracking it out if it hits a hard spot. So here's the first hole drilled down to depth. Didn't blow through anywhere, didn't hit any hard spots. Got the pretty much same wall thickness all the way down. Looks really good. It's a nice clean hole. Notice it's a little sloppy, and that's fine, because I'm gonna, when I'm all done and ready to seat these permanently, I'm gonna go ahead and epoxy them in place so that they fills up all the gaps, takes up all the space, and it reinforces the wood that I took out by replacing it with metal and epoxy. So it'll keep the structure and strength of the wood real well. I want to talk about a little side note here for a second. The style of underlever that I build, you know, most people know me primarily as a muzzleloader builder, but I do these underlever cartridge guns in these big 2-bores, and the style that I build is the Jones patent rotary underlever action. And the patent that I use, and he had several, but the patent that I mostly build is the 1856, which is the earliest one. If you take that into account, 1856, most of the tooling in 1856 was, you know, if you're talking power tooling like lathes, mills, drill presses, that kind of thing, most of it was belt driven, either off of steam or waterworks or something along those lines. So their power tools were, you know, kind of limited, and their location for where they could build was kind of limited because you had to have the resources to run the tools. So a large portion of their work, and a lot of the things that they built in the 1850s, were done with tools just basically not much different than the one that I'm using today. This, you know, hand drill isn't too much different than an original as far as design goes. The chuck itself is a little different than the originals, but overall it works the same way. And so, you know, I wanted to mention that if you ever want to get a grasp on the kind of craftsman it took in the 1850s to build these types of guns, beg, borrow, or steal one of these from somewhere. I don't mean that literally, obviously, but beg or borrow one. Get yourself a nice chunk of hardwood, and you know, get a drill bit, and you know, even a 1/4 inch bit. Get a 1/4 inch drill bit, and stick it in a hand drill, and drill yourself a 4-inch hole through a piece of hardwood with a 1/4" drill bit. And this is, you know, modern steel, modern heat treat, modern bit and everything. Just hand drill yourself a 4" hole once. You'll have a newfound perspective and a considerable amount of respect for the craftsmen of the 1850s and all their predecessors, you know, that go back to the 1600s and, you know, early guns of the 1600s, that kind of stuff, with the very beginnings of gunpowder. And you'll find a new respect for the craftsmen who were able to really, you know, make these works of art that date back, you know, several hundred years, when you consider that, you know, the tooling they had to work with was basically all hand-driven tools. You know, today, right now in my shop, it's probably 85, 90 degrees in here, and I've got an electric fan blowing on me to kind of keep some air moving and keep me cool. And it took me about 10, maybe 12 minutes to carefully drill this single hole here with that hand drill. You know, can you imagine what it'd be like working in the 1850s? No fans, closed up shop, no really good lighting like we have today, no electric lighting, and almost all of your work, start to finish, was done with, you know, hand-driven tools. And you know, so you look at the works of some of the famous gun makers, and you look at the craftsmanship and the quality of the craftsmanship and how long those guns have endured, and it's just really amazing to think about the terms that they built them under. So, just a little side rant, my perspective on things. But if you ever want to experience, you know, what it was like to work these kind of guns back in, you know, 100, 150, 200 years ago, get yourself a hand drill and take a drill bit and run it through a piece of hardwood a couple times. See how long it takes you to drill even a 1/4" hole, and see what kind of a workout you get from it. Well, it's a pretty close fit, as you can see. Even broke down the walls in between just a little bit to get enough room to squeeze all 3 of those together. And this one's still a little loose, but these are all pretty snug in there. And so when I fill this in with epoxy, it'll you know, take up all the empty gaps, space, fill everything in, and lock the wood in real tight to the recoil reducers. Of course, I'll have to take all the coating and stuff off of them and rough them up a bit so that it really locks them in. But that's how it's going to look, and I'm about to put the recoil pad back on. I had it on just a second ago to make sure everything was snug down and would fit good, but everything clears and everything works, so managed to get all 4 of them in there. Of course, this isn't a normal application, but obviously if you were doing this for, you know, a normal gun or trying to weight it or counterbalance it, usually you'd only use 1, maybe 2 of these, depending on the size of caliber it is. And they'd be, you know, you'd try to, depending on where your balance points and stuff are, you may try to, you know, screw them together and run them, you know, as one down the length of it to put more weight forward, so it's not all at the back. Just some things to think about if you're going to put recoil reducers in any of your guns. You know, keeping your balance points and knowing where to put your weight. So that's that part. I'm going to put this all back together. I'm going to put the gun back together, see how it feels in my hands, and then I'm going to throw it on a scale and see what it weighs, so I get a rough idea of the finished weight on this. So I weighed it. It weighs 42.5 pounds right now, and that's without the top rib and the section of rib that goes from the swivel point forward on the bottom. So it's still missing a couple of rib pieces. I did set the front side up on there. I wanted to show you where the balance point is, because you'll see that I've got it pretty close to balanced here. It's just a little muzzle heavy because I don't want it falling on the floor. But by the time I put the ribs on there, that's going to move the balance point even farther forward. And so really this thing's still, even with all the weight I added to the back of it, it's still muzzle heavy, which it's not terrible, but it does put your balance point past your forward hand, which isn't really ideal for a double rifle. That's balance point should be closer to the action, so where the balance is in between your hands. But that's honestly about the best I can do with this setup, with the barrels being spec'd the way they are. Shorter barrels turned to a lighter taper. The gun would have looked kind of short and stubby, but it would have balanced and swung better, and it would have weighed quite a bit less. So just kind of the way it is. You know, the customer wanted this particular setup because of the looks and the shape and size of the gun. So having a little barrel weight on it you know, honestly, this gun's really not something a guy can shoulder up and shoot offhand, because his sight picture, it drifts, you know, down so fast anyways. You pretty much have to shoot this thing off of a rest or off of sticks if you're in the field. Having that little bit of extra on the muzzle may not be so bad at that point. It'll keep the gun from jumping so bad, and this, you know, this kind of recoil will have a lot of muzzle rise to it, so that will help that some. But honestly, that's probably as good as the balance point's ever going to get. It's just going to be forward on the forearm from there. So overall, not a bad looking rifle though, and you know, the weight being up there above 40 pounds is kind of disappointing to me. I would have liked to have had it down in the 30 pounds, you know, the 35 to 40 pound range, but I think it's still going to be a workable gun. Not obviously for the lightweight. A guy really needs to muscle up to be able to handle this thing, but it should be shootable, and the recoil, you know, with this big of a cartridge and the kind of powder charges you can potentially run in it, that kind of weight really probably isn't going to be a bad thing. Should tame it down quite a bit. Okay, the next step in this is going to kind of seem a little out of order for normal gun building, but there's a method to my madness, so bear with me here. I'm going to pull all these screws, and I'm going to countersink and replace them with what will end up becoming the finished screws. I'll do it on all these, the ones down here, the ones in the grip cap, trigger guard. I'll pull all these screws, replace them with finished screws, and then what I'm going to start doing is I'm going to file down to fit, and I'll pull these locks apart again and put the plates, just the plates, back in, and then I'm going to start doing some, you know, touch-up file work to kind of clean some spots up and even things out, and then I'm going to sand this down to basically a finished sand. I'm going to take it, you know, through the grits from file to 60 to, you know, working up in grits from 60 to 100, 120, 150, 180 on up till I get to about a 400 grain finish, 400 grit finish. And what I'll do is, the reason I'm doing this, the reason I'm taking this whole thing to a 400 grit finish right now is because this action is made out of 8620. And before I can shoot this and regulate it, I need to have the action completely finished, the engraving done, and then I need to, the finish that the customer wants on this is color case hardening. So I need to do the color case hardening on the action parts, the underlever, the action body and whatnot, and get it finished hardened to its finished hardness, heat treat and temper with color case finish on it, so that I can safely shoot it, proof test it, and know that it's going to handle these cartridges and work properly, and then I'll be able to do the regulation work. And of course I've got to make a few other things before I can regulate. I've got to do some reloading tools and stuff for these 2-bore cartridges and do some of that work. But so this is going to get a little out of order compared to what would be a normal build, but the reason it's going to be out of order is because I need to get the action heat treated, tempered, color case hardened, all the metal finish work done on the action, and the underlever parts, the parts that actually mechanically make the gun safe to shoot, so that I can do the regulation work on it. And so that's where I'm at. It's going to be several days, actually probably more than several days with as big as this thing is, as much metal work there is, of sanding and polishing and filing and fitting. And so I'm just going to start by getting finished screws in everywhere, and then I'll go from there with getting the rest of the finish work done on it. And so there probably won't be a whole lot of, you know, new video to watch over the next couple days, and probably most of next week. It's just going to be a lot of file work, sand work, and finish work up to this point. And so that's what you're going to look forward to next week probably. Once I get these screws and stuff in place and get them timed out, I'll shoot a little bit of video to show you what that looks like. And then the rest of it's going to be basic finish work, so pretty boring, not much to film or see that's exciting there, but I'll try and get enough video put together to make it worth looking at for the next week's work. So that's where I'm at. So I got all the screws replaced, countersunk, and indexed, so that they're all running parallel to the bore line. I did this top, bottom, trigger guard, grip screws, all the grip cap screws, all that. It all looks just like this. All the screws are countersunk in, they're all indexed in, and these will be the final finished screws. So I really want to be careful not to tear these up, taking them in and out. So I want to use the right screwdriver and stuff is what I'm saying. But my next step here is I'm going to take the hammers off. I'll leave the rest of the locks together for the time being. And I'm going to come in with a fine cut file, and I'm going to start taking all these aggressive file marks out. The stuff that I did, most of the shaping with, left some pretty deep file cuts, and so I'm going to come with a fine cut file. And I'll take these screw heads down to flush and work the edges of wood to metal, and work all of the metal down, taking all the rough file cut out. And then once I get the whole thing down to where I've got a nice finish with the file, then I'll come in and I'll start sanding all this stuff. So that's where I'm at. It's going to take me a while to do this. It's kind of a tedious little process. Got to just keep working it down and taking the gouges out of it, basically. So that's where I'm at. As you can see, things are starting to clean up pretty good now. You can see I've still got some pretty deep file marks in here, and so I'm still working this with a very fine file to get these out. There's a few other little spots that I need to work on where there's some file marks still. But overall, you look like over the barrel where I've got this part down to 100 grit paper now, where I'm down to sanding and instead of filing. And you look up here where the monoblock seam originally was, and it's pretty much disappeared. There's still a real faint line right there, and hopefully as I sand it down even further, that'll get even lighter, but it's starting to disappear, and that's really what I was hoping for. I was hoping for a really good clean fit like that would make that virtually seamless when I'm all finished with it. So hopefully everything turns out like that where I can make it all disappear. There's still a little bit of a seam line here at the breech face, and I'll clean that up as best I can, and hopefully it'll mostly disappear as well. This one here will always show just a hair because it does open and close, obviously, so it's never going to be a perfectly seamless fit, but getting it down to a real fine line like this is what I'm ideally looking for. And then of course removing all the major marks from off of that piece there, and getting those to go away. And so this is basically file work, paperwork, and then the lock and whatnot is starting to turn down to where it's down to about 100 grit with almost all the locks. So it's coming along. I'm going to take a few other shots here, change some camera positions. Customer wanted to see what the muzzles looked like, since I hadn't showed any pictures of a direct on shot of the muzzles since the very beginning of this project. So I'm going to change camera positions and show what that looks like, and that's pretty much going to wrap it up for the week. Next week I'll start back over with continuing to work on this and get it all filed down and sanded down and get it down to a finish. And then we'll see about hardening and treating this action and these other parts so I can do the regulation work. My customer requested this shot. He wanted to see what the muzzle end looked like now that it was starting to come together. And so here's a quick shot of the muzzles and down the length of the barrels. Pretty intimidating from this end.